Today we're going to be talking about ratios and similar polygons. We will be able to use ratios and proportions to write and solve equations, and we will be able to identify similar polygons and use them to find missing side lengths and angle measures. Polygons are similar if the ratios of their sides are equal. So are the following triangles similar? If so, state the scale factor and write the similarity statement. So the first thing we need to check are the ratios for all the sides. So we're going to look at the small sides, the medium sides, and the large sides. And we're going to pair them up. So the longest side in ABC, the smallest side in ABC is the side AC, which is 4. In FDE, the smallest side is 2. 4 over 2 simplifies to 2 over 1. The medium sides would be AB, which is 6, and DE, which is 3. 3 over 6 simplifies to 2 over 1. The largest side in ABC is BC, which is 8, and FE, which is 4. Again, it simplifies to 2 over 1. If all the ratios are equal, which in this case they are, then the polygons are similar. And it has to be all of them. It can't just be 2 of them. Determine the scale factor. Well, technically, we already did. These are our scale factors. So our scale factor is 2 to 1. That tells us that the bigger triangle is twice as big as the other triangle. Now we're going to write a similarity statement. Triangle ABC is similar to triangle. Now here's the thing we have to be careful of. We need to be very careful of the order of the letters. Just because A is in this left corner and so is F does not mean that they go together in the similarity statement. A to B, which is our first 2 letters, was our medium side. So we need to match it up with our medium side in the small triangle. So DE, and then from B we went to C, which was the long side, which is E to F. So it's triangle DEF. Now what transformation does this remind you of? That's right, it's a dilation. So now let's look at things when they tell us that they're similar. It tells us that triangle ABC is similar to triangle EDC. Find the length of DC. So since we know they're similar, we know their sides are going to be proportional. We know the ratios will be equal. So we know that AC over EC, because those are 2 of our givens, has to be equal to DC. I'm going to put it down here. But what side of ABC matches up with DC? Well, DC is the last 2 letters, so we need to know what BC is. So we know that AC is 8, EC is 4, tells us DC is X, but what's BC? This whole length from B all the way to D is 10, and we know that CD or DC is X, so BC is whatever 10 minus X is. Now, since we have a ratio, we're going to cross multiply. 8 times X is 8X, and then we're going to have 4 times 10 minus X. We're going to distribute. Add 4X to both sides. We get that 12X equals 40. Divide both sides by 12. And we get that X equals 10 over 3. Given the similarity statement that ABCD is similar to WXYZ, find the scale factor and find the missing values. So to find the scale factor, we need to use the sides that were given. In A, B, C, D, the only side we're given is AD. So A and D. So we know it's got to be 14 over something. Now, which side matches up with AD in our similarity similarity statement? That would be WZ, because A and D were the first and last letters. We use the first and last letters here, which is a length of 10. Then we simplify 14 over 10, which is 7 over 5. Now we're going to find the missing side lengths. Let's start with P. That's CD. So CD would match up with YZ. So P over YZ is 3. Has to come out to equal 7 over 5. Cross multiply. 3 times 7 is 21. P times 5 is 5P. Divide both sides by 5, and we get that P equals 21 bits. We're going to set up the other ones the same way. If we're looking for M, that's BC. BC goes with XY. So M over XY is 4. It also has to equal 7 over 5. Cross multiply, 28 equals 5M. Divide both sides by 5. We get that M equals 28 over 5. And finally, K is AB, so it goes with WX. K over 8 equals 7 over 5. 8 times 7 is 56 equals 5K. Divide both sides by 5. K equals 56 over 5. That's all for today. I'll see you in class.